Okay, so let's look at some trig ratios that you really need to remember. I don't remember them off by heart, but I just remember the triangles which they come from. So let's look at the first one. All right, let's take a isosceles right angle triangle. Let me try and draw a triangle which looks like two sides the same. This doesn't, clearly, but right, that looks right angle-ish. Alright, that's the right angle. Let's say this side is 1 unit long, 1 centimeter, and this side is 1 unit long as well. Okay, 1 centimeter, 1 meter, whatever. Okay, right, using Pythagoras, if you do 1 squared plus 1 squared, that equals this missing side squared. Well, 1 squared is 1, and so we're just doing 1 and 1, which is 2, and then, okay, well then we'd have to square root that at the end, so this side would be root 2 according to Pythagoras. Okay, now, what would be the angles here? Well, okay, that's 90, well this would have to be 45, okay, because it's an isosceles triangle, and then this would have to be 45 as well, okay, but in radians, what would they be in radians? Well, this would be pi over 4, okay, we need to use radians, okay, because we just do, we're mathematicians, we like radians. Okay, so that's what it would be in radians, okay, pi over 4. Now, let's use our SOHCAHTOA, okay, our trig ratios to work out certain values you should remember, okay? Now, right, let's use the first one here. So, I meant to say so. Right, sine of the angle, okay, let's pick one angle. Well, they're both the same, so it doesn't really matter. Okay, so let's pick this angle as our angle of interest. 45 here, so sine 45. Right, according to that angle, what's its opposite? Well, it would be this. This would be the opposite to the angle. This would be the adjacent, and this would be the hypotenuse, right? Opposite the right angle. So sine 45, or sine of, what is it in radians? Pi over 4, would equal the opposite side, which is 1, divided by the hypotenuse, which is root 2. So sine 45 is the same as 1 over root 2. Now let's just check that on our calculator. So we're working in degrees. Okay, so let's do sine 45, press enter. What number do we get? 0.707107. Okay, now let's do control, divide to get fractions up. Let's do 1 divided by the square root of 2. Okay, press enter, we get the same number. So this is one ratio you should remember, okay, because on a non-calculator exam, you may have to work out what something like this would be. Something like, let's say 5 times sine 45, right? Okay, but you know what sine 45 is because you remembered this, so that's 1 over root 2. So you can say that's just the same as doing 5 times 1 over root 2. Well, that'll be 5 over root 2. So you've just worked out sine 45 without using calculators, just by remembering this identity. All right, let's go through the others. Cosine 45, or cosine of pi over 4 equals the adjacent, okay, which is 1, divided by the hypotenuse, which is root 2. So cosine 45 is the same as doing 1 divided by root 2. Okay, and then the last one, tan 45 would be the opposite over adjacent, so the opposite is 1 and the adjacent is 1, so 1 divided by 1 is 1. Okay, so tan 45 is 1, and tan of pi over 4 would also be 1 if you got your calculator set up in radians. Okay, so remember these identities because you might be asked to do something like this, okay, or maybe that's part of the problem. Okay, I don't remember these off by heart necessarily, but I just remember this triangle and I can work out these here. But really, you should, I mean, if you want to be a really good mathematician, you should commit these to memory. Okay, right, the second triangle to remember, I'll tell you where it comes from first of all. Let me do it in a different colour now. Okay, take an equilateral triangle. Okay, this is looking like the worst equilateral triangle ever drawn, but take an equilateral triangle where the sides are all 2 units long, 2 centimeters or 2 meters or whatever. Okay, they're just too long. No, as in too long, not too long, as in they're 2 units long. Right. Now the angles in the corner of an equilateral triangle are all 60, aren't they? 60 degrees, 60, and 60. Now take that equilateral triangle, chop it in half. Okay, like that. If you chop an equilateral triangle in half, you get a right angle triangle. Right. Let me draw that let me draw that right angle triangle out here. So if we go through this, go through the angle, sorry, that's 90, that would be 60. Okay, so what's 60 degrees in radians? That's pi divided by 3. And this angle would be 30, but in radians it would be pi over 6. Right, this side's 2 units long, and then if we chop that side in half, then this would be 1. Again, I'll let you work out this particular side, but for yourself. But using Pythagoras, that's the hypotenuse. That's the c part. A squared plus b squared equals this side squared. And so you're working backwards a little bit. This would be root 3. Okay, I'll let you work that out for yourself. I'm trying to keep this under 15 minutes, this clip, okay, and I'm doing okay so far. Right, now, using SOHCAHTOA, again, let's see what other ratios we can get out of this. Okay, so let's pick one angle first of all. They're different angles, so we get some different ratios. So this, let's say this 60 degrees is our angle of interest. Okay, so if that's the angle of interest, this would be the opposite, this would be the adjacent, and then this would be the hypotenuse, right? Okay, so let's work out sine of 60, or sine of pi over 3. Sine 60 degrees is, well, according to this triangle, is opposite over hypotenuse. The opposite is root 3, and the hypotenuse is 2, so that would be root 3 over 2. So if you did sine 60 on a calculator, it's the same as doing root 3 over 2, and you can check it for yourself. This is the same as this. Okay, going through the others, cosine 60 degrees, cosine pi over 3 in radians. Cosine is adjacent over hypotenuse, so the adjacent is 1 and the hypotenuse is 2, so 1 over 2. Cosine 60 is a half. We can check that quickly actually. Trig, cosine 60, press enter, you get 0.5, which is a half. Right, and last one, tan 60, tan of pi over 3. Tan is opposite over adjacent. Opposite is root 3, and the adjacent's 1, so root 3 divided by 1. Well, root 3 divided by 1 is just root 3, isn't it? It's anything divided by itself is just, anything divided by 1 is just itself anyway. So tan 60 over tan of pi over 3 is just root 3. Okay, so there's one set of ratios you need to remember. And a similar thing, if someone asks you what 5 times cos 60 is, okay, well, you know that cos 60 is a half, so be 5 times a half, well, it'll be 2.5, right? Okay, very bad handwriting at the bottom. But that's the type of thing you'll be doing. Okay, now using the 30 degrees as our angle of interest. Okay, so the 30 degrees, so let me rub this out. Well, according to that 30 degrees, this is its opposite side, and then this would be its adjacent, and then the 2 would remain as the hypotenuse. So let's go through the trig ratios again. Sine 30 degrees, or sine in radians of pi over 6, is the same as doing the opposite divided by hypotenuse. So opposite over hypotenuse is 1 over root 2. So this is its opposite, and the hypotenuse is 2, so 1 over root 2. So sine 30 is the same as a half, or sine pi over 6 is the same as half. So whenever you see this or this and you're taking sine of it, that's the same as a half. Okay, and then cosine 30, or cosine pi over 6, is the adjacent divided by the hypotenuse. So the adjacent is root 3 over the hypotenuse, which is 2. So cosine 30 is the same as doing root 3 divided by 2. And then tan 30, or tan of pi over 6, is opposite over adjacent, so 1 over root 3. Okay, so these you really need to remember. Really, you should commit these to memory, because we're going to use these a hell of a lot, really. So make sure you know them, okay? Or make sure you know this triangle and you know where these come from, all right? But try and commit them to memory. But if you're a bit lazy like me, I just remember the triangle. But know this, okay? Know it. I'm going to say it one last time. Make sure you know this. Okay, and the next clips will probably come across these at some point. Okay, so just commit these to memory, please. Thank you.